We are continuing in Chapter 2, Reasoning and Proof, and today we are going to be talking about inductive and deductive reasoning. So let's start off with the difference between the two. Inductive reasoning is simply logic based on noticing a pattern. Okay, we are looking at the pattern and we're trying to figure out what would come next. Okay, deductive reasoning is logic based on concrete facts, definitions, and laws. Okay, so let's take a look at a couple examples of inductive reasoning. So complete the pattern. So let's start in and we look and we say 1, 4, 9, 16, 25. So we start looking at that logically and we try to figure out what are these numbers? Is there a common difference between them? What's going on with that? So what we do is we take a look at that and we say, oh, they're perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So the next two in the pattern would go 36 and 49. And it would keep going. It would just be all the perfect squares. If we look here at this second one, we'd start off and we'd say 1/12, then 2/17, 3/22, 4/27, 5/32. So as I look across, I see that the numerator is increasing by 1 each time, but the denominator is increasing by 5 each time. So this would end up being 6/37 and then 7/42, which would be 1/6. Okay, so that would be that pattern. Then if we look here at an alphabet one, we have A, C, E, G, I. Well, if we think about it, we have A, B, C, D, E, F, G, H, I, J. So the next one in the pattern would be K, L, M, and then it would keep going as well. Okay? So that is using inductive reasoning, basic logic based on noticing a pattern or not. Deductive reasoning is using those facts, definitions, laws, those types of things. And we have two laws that we're going to focus in on. We are going to focus in on the law of detachment and the law of syllogism. So let's start with detachment. Law of detachment simply says, given a true conditional statement, if the hypothesis is true, then we know the conclusion will be true. The way I also like to say this is if we know P then Q and P is true, then Q is true. Okay, now the law of detachment does not say anything about P then Q and Q is true. We don't know P is true. So we have to be told that the hypothesis is true, then we know the conclusion. So in this example, if it's the weekend, P, that's the hypothesis, then I'll play video games. It's the weekend, so P is true. What can we conclude? I'll play video games. Okay, so if we map it, we have P, then Q, and we know P is true. So automatically, we know that Q is going to be true. Let's try another one. If you pass the final, then you pass the class. You pass the final, what can we conclude? You pass the class. So when we look, you pass the final, that's P. You pass the class, that's Q. You pass the final, so that's telling me P is true. So then Q must be true. Okay, let's try the next one. If you're a sophomore, then you're in high school. You're in high school, what can you conclude? No conclusion. So notice the difference here. If you're a sophomore, that's our P. Then you're in high school, that's our Q. We're told that Q is true. So based off the law of detachment, we cannot draw a conclusion that you're a sophomore. Because in order to use the law of detachment, it has to be the hypothesis that's true, the P that's true, in order to conclude that the Q is going to be true. All right, now we go to the law of syllogism. The law of syllogism simply says, if P then Q and Q then R, then P then R. This is very similar to a property you've probably heard before. It is called the transitive property of equality. Okay? And what it looks like is you've got to make sure that the Q's go together, then the P is going to go to the R. So if we look here, it says, if a shape is a rhombus, then the shape is a quadrilateral. If a shape is a quadrilateral, notice those Q's are the same, then it has four sides. So what can we conclude? If a shape is a rhombus, then it has four sides. Okay, so if P then Q, here's my P, here's my Q, and if Q then R, then I know P goes to R. Okay, so let's try another one. If you do your homework, so that's our P, then you can watch TV. That's our Q. If you watch TV, that's our Q, then you can watch your favorite show. That's our R. So what can we conclude? If you do your homework, then you can watch your favorite show. So using the law of syllogism, that works. So let's go to this last one here. If a polygon is regular, so that's our P, then all angles in the polygon are congruent. That's our Q. So we got P then Q. If a polygon is regular, that has P, then all its sides are congruent. R, what can we conclude? No conclusion can be drawn because it does not go in the right order. Remember, we got to go P to Q and Q to R. And then that gives us P to R. On this problem, we have it saying P to Q and P to R. So we cannot conclude Q to R. That is a no. We can't do that. So using the law of syllogism, it has to map out correctly. P to Q, Q to R, then we know P to R. And that is our inductive and deductive reasoning.